Hello dear students, welcome back to physics online session. So since from that couple of days we discussed about electrostatic potential and capacitance. So in that chapter, we discussed about electrostatic potential as well as capacitance. So for our theory examinations, so this chapter will carry for 9 marks. So already we discussed a neat aspect as well as theoretical aspect related to second chapter. So today we will be discussing on NCERT numericals related to electrostatic potential and capacitance. So let me begin with the numericals here. Okay. Two charges 5 into 10 to the power of minus 8 coulomb and minus 3 into 10 to the power of minus 8 coulombs are located 16 centimeter apart. So they mentioned that two charges are there. So between these two charges there exists a certain distance here. So first I will take that magnitude of the charge. So Q1 is 5 into 10 to the power of minus 8 coulomb and Q2 is minus of 3 into 10 to the power of minus 8 coulomb are located 16 centimeter apart here. So what is the distance between these two charges? 16 centimeter apart here. At what point on the line joining the two charges is the electric potential 0? Take the potential at infinite to be 0. So which thing I need to find out here? So null point. So where that potential value is 0. So that point is 0 potential or null point I can consider. So in our neat aspect, so we are having that general formula x is equal to d divided by q2 by q1 plus or minus of 1. But in theory examination we are not supposed to use this direct formula. So let me solve that answer for that usual method only. So look at here. So first I will give that diagrammatic approach for this question. So look at here, two charges they said, and between these two charges there exists a certain kind of separation. Let the distance be r here. Now I will choose that one point here. So that point is exist between the charge. So let P be a point where the potential is 0. So that point is between the charges. This point is at a distance of x from the charge Q1 here. So first one, between the charges. So potential 0 potential is exist between the charges here. So this point is I consider between the charge Q1 and Q2. So total potential must be 0 here. V1 plus of V2 is equal to 0. So null point means total potential is 0. Shall I take that V1 is equal to minus of V2? So what is the formula for electrostatic potential in case of isolated point charge? So that is 1 by 4 pi epsilon naught q by, so what is the distance from that Q1 to point P here? So that distance is x here, and minus of 1 by 4 pi epsilon naught q of 2. What is the distance of this point of observation from the second charge here? So look at here, total distance is r, this distance is x, means what about the remaining distance? Shall I take that r minus of x here? So remaining distance will be r minus of x here. So hope you are understanding these things. 1 by 4 pi epsilon naught term will getting cancelled out. Q1 by x, it is equal to minus of Q2 divided by r minus of x. So what's that value here? Q1 value 5 into 10 to the power of minus 8. So x value is yet to be determined here. Q2 value is how much? Minus of Q2 is minus 3. Minus into minus. So for example, minus of magnitude. So charge on the second body. So minus 3 into 10 to the power of minus 8 divided by r value is how much? So r value is 16 here. So 16 minus of x here. Okay. So 10 to the power of minus 8, 10 to the power of minus 8 term will getting cancelled out. Minus into minus, that is plus here. 5 by x, it is equal to 3 divided by 16 minus of x. So make that cross multiplication here. So 5 into 16 minus of x. So it is equal to what? So 3x here. So 5 into 16, so 16 into 5, so that is 80 here, minus of 5x, it is equal to 3x here. So minus 5x, if it goes to right side, 80 is equal to 8x. So 5 plus of 3, so x is equal to 80 by 8, 8 ones are 8 tens are, so x is equal to 10 centimeter. What is the location of that null point here? So null point is exist at a distance of 10 centimeter from that positive charge. At a distance of 10 centimeter from the positive charge, zero potential is exist, or at a distance of, so total distance is 16, so this is 10, remaining distance is what? 6 centimeter from the negative charge and 10 centimeter from the positive charge. One more possibility of zero potential is there, so that is potential, zero potential is exist outside the charges even. So potential is zero outside the charges. So one more condition I will take it here. So for example, again two charges, so one is q1, another one is q2, and separation between these two is r amount of separation is there. So I will take that point of observation, let p be the point of observation at a distance of x from the positive charge. So this point of observation is at a distance of x from the positive charge here. So look at here, so from the positive charge to point of observation is x distance here. And what about the distance q2? So from the charge q2 to point of observation, what is the distance? This distance is r, this distance, sorry, this distance is, so this distance is x, this distance is r, I mean remaining distance is x minus of r. So similarly I can take that v1 plus of v2 is equal to 0, again that v1 is equal to what? Minus of v2. So same thing, 1 by 4 pi epsilon naught q1 divided by, from that q1 to point of observation is at what distance? X distance, and minus of 1 by 4 pi epsilon naught q2 into, what is the distance from that charge q2 to point of observation here? X minus of r, so this is x, this is r, and this distance x value is greater than the r here, so that's what x minus of r I will take, x minus of r, 1 by 4 pi epsilon naught term will getting cancel out here. Again that q1 value is what? 5 into 10 to the power of minus 8, x value, it is equal to minus of 3 into 10 to the power of minus 8. So x minus of r, r value is how much? 16 centimeter here, sorry, x minus of r here 10 to the power of minus 8 term will get cancel out, 5 by x, minus into minus plus, so x minus of r here. So make that cross multiplication here, 5 into, sorry, 16 here, x minus of 16, x minus of 16, it is equal to 3x here, 5x minus of 80, it is equal to 3x, minus 80 if it goes to plus 8, 5x minus of 3x, so that is 2x here, 2x is equal to 80, x is equal to 40 centimeters. So look at here, outside the charges also, outside the charge also there exists a zero potential, so at a distance of 40 centimeter from positive charge, from the positive charge, at what distance zero potential is exist here? At a distance of 40 centimeter from the positive charge. Then at what distance from the negative charge here? So negative charge means x minus of r here, 40 minus of 16, so that is 24 centimeter from the negative charge. So hope you're understanding these things. So in order to get that zero potential, so there are two possibilities. So zero potential is exist between the charge, and as well as zero potential is exist outside the charge also here. So we'll look at next one. We'll look at next question here. A regular hexagon of side 10 centimeter has a charge 5 microcoulomb at each of its vertices. Calculate the potential at the center of the hexagon. So look at here. So this is one hexagon here. Okay. So at each corner they were placing that 5 microcoulomb charge. 5 microcoulomb, 5 microcoulomb here, 5 microcoulomb, 5 microcoulomb. And they said that hexagon of side 10 centimeter has a charge of, so side value is 10 centimeter, and they asked to determine that what is the electrostatic potential at the center of the hexagon. So total potential. So in order to get the total potential, so V is equal to 1 by 4 pi epsilon naught Q by R here. So distance is 10 centimeter they mention, and charge value is 5 microcoulomb they mention. So how many corners are present here? 6 corners. So I will take that V is equal to 6 into 1 by 4 pi epsilon naught Q by R here. So 6 into 1 by 4 pi epsilon naught value is how much? 9 into 10 to the power of 9. So charge value is 5 into 10 to the power of minus 6. So distance value 10 into 10 to the power of minus 2 here. So what's that V value? 5 ones are 5 twos are 9 into 3, 27 into 10 to the power of 9 minus of 6 here. So that is 9 minus of 6. So that is 3 here. So if it goes to numerator, plus 2 here. So V is equal to 27 into 10 to the power of 5 or 2.7 into 10 to the power of 10 to the power of 6 volt here. What is that answer here? Potential value is 2.6 into 10 to the power of 6 volt. Okay. We'll look at next one, 2.4. 2.3 is a theoretical question. Look at the question 2.4 here. A spherical conductor of radius 12 centimeter has a charge of 1.6 into 10 to the power of minus 7 coulomb distributed uniformly on its surface. So look at here, one sphere is there. So that sphere having the radius 12 centimeter here, and that sphere having a charge of, it has a charge 1.6 into 10 to the power of minus 7 coulomb. So or 16 into 10 to the power of minus 8 coulomb here. Charge is 16 into 10 to the power of minus 8 coulomb distributed uniformly on its surface. What is the electric field inside the sphere? So first thing, so generally we know that from that first chapter related question it is, so electric field inside the conductor is 0. So answer for that first one is 0 here. And second one, just outside the sphere here, outside the sphere means radius. So for example, this is one sphere and they mention that R here. So they asked to find out that what will be the electric field on the surface here. So I am having generalized formula for electric field here, 1 by 4 pi epsilon naught Q by R square. So don't get confused here. So this is about field and this is about potential here. So 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9. So charge value is 16 into 10 to the power of minus 8. So R square. So 12 into 12. So 12 into 12, 10 to the power of minus 4 here. So simplify this equation. So 1 into 10 to the power of 9 minus of 8. So that is 10 to the power of 1. So minus 4 if it goes to numerator, plus 4. So E is equal to what? 1 into 10 to the power of 5 Newton per Coulomb. So what is our answer here? electric field just on the surface of the sphere is 1 into 10 to the power of 5 Newton per Coulomb here. So next, third sub question they ask, at a distance of 18 centimeter from the center of the sphere. So this is radius, and one more point they consider here. So for example, r is equal to r. So at a distance of 18 centimeter from the center they mention, from that center to 18 centimeter. So this is the situation. So electric field, so it means that point of observation is outside the sphere. So 1 by 4 pi epsilon naught q by r square, same formula. Electric field outside, 9 into 10 to the power of 9. Q value is how much? 16 into 10 to the power of minus 8. So r square. So distance is 18 centimeter they mention. So 18 centimeter. 18 into 10 to the power of minus 2 meter here. 18 into 18, 10 to the power of minus 4 here. So that is electric field outside that sphere. So 4 into, so 10 to the power of 9 and 10 to the power of minus 8. So that is 10 to the power of 1. So that I can take it as a 40 here. 10 to the power of minus 4, if it goes to numerator, 10 to the power of 4, 9 here. So 9 4s are 36. So again 4 remains. So 4.4 here. So electric field outside is 4.4 into 10 to the power of 4 Newton per Coulomb. So what is that answer here? So electric field outside the sphere is 4.4 into 10 to the power of 4 Newton per Coulomb here. So we'll look at next one. So in case of that electrostatics, so that electrostatics means it covers the two chapters. So that electric charge and field as well as electrostatic potential and capacitance. So combinedly we can call it as a electrostatics. Okay, we'll solve next question. A parallel plate capacitor with air between the plate has a capacitance of 8 picofarad. So pico means 10 to the power of minus 12 farad here. Capacitance of parallel plate capacitors, air is act as a dielectrics or without dielectrics. That C naught value 8 picofarad here. What will be the capacitance if distance between the plate is reduced by half? So I am changing the distance here. Distance between the plate is reduced by half and space between them is filled with the substance of dielectric constant 6 here. So what about the new capacitance? So we are having that generalized formula. So C is equal to K into epsilon naught into A divided by D. So they are changing the distance value here. C is equal to K into epsilon naught into A divided by. So half of the initial distance, so D by 2 here. So denominator goes to numerator. So shall I take that into 2 here? Or you can take it as a 2. So D by 2. So fill the value. K value is how much? K value is 6 here. Epsilon naught into A divided by D. I can take this one as a C naught. What its value? So 8 into 10 to the power of minus 12 pico means. So into 2. So what is our answer? 12 into 8 here. So that is 96 picofarad. So what is our answer? So capacitance is 96 picofarad here. So next one. Three capacitors of each capacitance 9 picofarad are connected in series. So 3 capacitors they mention, and these 3 capacitors having that capacitance value 9 picofarad, and all these 3 capacitors are connected in series combination. C is equal to 9 picofarad or C1, and C2 is also equal to 9 picofarad, and C3 is also equivalent to 9 picofarad here. And these capacitors are connected in series combination. what is the total capacitance of the combination? So first one, I need to find out that total capacitance of the combination. In case of series combination, this is the connecting formula. So 1 by C of S is equal to 1 by 9 plus 1 by 9 plus 1 by 9. 1 by C of S is equal to, if I take that LCM 9, so 1 plus of 1 plus of 1, 3 by 9, 3 ones are. So 1 by C of S is equal to 1 by 3 and C of S is equal to 3 picofarad here. What is that effective capacitance here? Effective capacitance is 3 picofarad, and they, in that sub question they mention, they asked to calculate that what is the potential difference across each capacitor if the combination is connected by 120 volt supply. So that combination is provided by that 120 volt supply, then what about its individual potential difference? In case of series combination, total potential difference is equal to sum of the individual. I got that effective capacitance as a 3 picofarad here, and they mention that voltage is 120 volt. First I want to calculate that what is the charge here. So C of S is equal to Q by V here. Q is equal to C of S into V. So why? Because in case of series combination, anyhow charge will be remain same. C of S is 3 picofarad here. So 3 into 10 to the power of minus 12 here. So V is how much? 120 here. 120 into 3 here. So 120. So that is 360 picocoulomb here. So 360 picocoulomb, or 360 into 10 to the power of minus 12 coulomb here. Now let me find out that individual potential difference, or individual potential difference. So C1 is equal to Q by V1, or V1 is equal to what? Shall I take this one as a Q by C1 here? Q value is how much? So 360 here. 360 picocoulomb divided by 9 picofarad here. So pico means 10 to the power of minus 12. Both will getting cancelled out here. So 9 4s 40. V1 is equal to 40 volt. Identical means V2 is also equal to 40 and V3 is also equal to 40 volt. So look at here, individual or branch potential difference V1, V2 and V3. So total potential difference is equal to sum of the individual in case of series. So look at here, 40 plus of 40 plus of 40. So that is again 120 volt here. Total potential difference is 120 volt. In each capacitor 40 volt, 40 volt and 40 volt potential difference is present here. So we'll look at next one. Okay, we'll read the next question. So 2.7. 3 capacitors of capacitance 2 picofarad, 3 picofarad and 4 picofarad are connected in parallel. So C1 value is how much? 2 picofarad. C2 value is 3 picofarad and C3 value is 4 picofarad. 4 picofarad. All these 3 capacitors are connected in parallel. First one, what is the total capacitance of the combination? So total capacitance in parallel combination. So C of P is equal to C1 plus C2 plus C of 3 here. So C of P is equal to 2 plus 3 plus of 4. C of P is equal to 9 picofarad. So what is the answer here? C of P is equal to 9 picofarad here. Next one, in sub question they asked, determine the charge on each capacitor if the combination is connected to 100 volt supply here. So potential difference is 100 volt. In case of parallel combination, potential difference is remain same. So I need to find out that charge on each capacitor, C1 into V here. C1 is how much? 2 into 10 to the power of pico means minus 12. So V is how much? 100. 100 is nothing but 10 to the power of 2 here. So Q value is how much here? So 2 into 10 to the power of minus 10 Coulomb here. So next one, C2 into V here. So C2 is how much? 3 into 10 to the power of minus 12 into 10 to the power of 2. 3 into 10 to the power of minus 10 Coulomb. So similarly Q3 is C3 into V. C3 is how much? 4 into 10 to the power of minus 12 into 10 to the power of 2. So 4 into 10 to the power of minus 10 Coulomb here. So these are all the branch charges here. So next one, in a parallel plate with air between the plates, each plate has an area of 6 into 10 to the power of minus 3 meter square. So in case of parallel plate, each plate having that area 6 into 10 to the power of minus 3 meter square. This is the area here. The distance between the plate is 3 millimeter here. So distance between the plate is 3 millimeter. Milli means 10 to the power of minus 3 meter here. Calculate the capacitance of the capacitor. So shall I find out that first one, C0 value. If the capacitance is connected to 100 volt supply, what is the charge on the each plate of the capacitor? So if that potential is 100 volt, then what is the charge here? So two unknown terms are there. So let me find out it. So I know basically capacitance of parallel plate capacitor without dielectrics or air is act as a dielectric. C0 is equal to epsilon naught into A divided by D. So epsilon naught means permittivity of free space. Its value is 8.85 into 10 to the power of minus 12. In the first chapter we got that value here. So area is 6 into 10 to the power of minus 3 and distance is 3 into 10 to the power of minus 3. 10 to the power of minus 3 term will get cancelled out. 3 ones are 3 twos are. So 8.85, nearly you can take it as a 9. So 9 into 2, 18 here. 18 into 10 to the power of minus 12 farad or 18 picofarad. So what is that answer here? 18 picofarad here. So they mentioned that what is the charge on the each plate of the capacitor. So if 100 volt is supply, what is the charge? C is equal to Q by V here. Q is equal to C0 into V here. C0 value is how much? 18 into 10 to the power of minus 12. Okay. So potential is how much? 100. So 10 to the power of 2. So then what is the charge on each plate here? 18 into 10 to the power of minus 10 Coulomb here. Or I can consider 1.8 into 10 to the power of minus 9 means nano Coulomb. 1.8 nano Coulomb here. So next one. So next question is continuation of this one. Explain what would happens if the capacitor is given in the exercise 2.8. So in that previous question, a 3 millimeter thick mica sheet of dielectric constant 6 is inserted between the plates. So here they mention that thickness is 3 millimeter and its constant value is 6. So look at here, whether the dielectric medium is completely filled or partially filled. So distance between the plate is 3 millimeter and thickness of the dielectric medium is also 3 millimeter. So it means that dielectric medium is completely filled between the plate. So in that situation, inserted between the plate, while the between the plates, so what would happens to the capacitance? So first I want to find out that capacitance after introducing a dielectric medium here. While the supply remains connected and after the supply was disconnected. So first one, if the supply remains the same, what would be its capacitance value? So C is equal to K into C0. K value is 6 here. C0 value is how much? C0 value is 18 here. So 18 into 6. So that is around about, so 108. So 18 into 6 means 108 picofarad here. What is that answer here? 18 into 6. So 108 picofarad here. Next one. So if the supply is remains same means, so this is the capacitance value here, and charge is also same here. So charge means what? So C is equal to what? Q by V. Q is equal to what? C into V here. 108 into 10 to the power of minus 12 into V means 10 to the power of 2. 108 into 10 to the power of minus 10 Coulomb, or Q is equal to 10.8 nano Coulomb here. So if the supply was disconnected in the second case, after the supply was disconnected here, so if that supply was disconnected means, so again that charge store will be remain same after the disconnected, so charge will be remain same, so that is 10.8 nano Coulomb here, but the potential will get decreases here. Initially